Intermediate Algebra Mid-Course Assessment, Questions 7, 8, and 9. For question number 7, the instructions read, solve the system of equations using substitution. Note that the system may be inconsistent or consistent with dependent equations. In number 7, we have the equations 9x minus 74 equals 7 times y, and negative 3x plus 4y equals negative 23. To solve by substitution, we need to solve for one of the variables in one of the two equations. Now, to do this, it doesn't really matter which one you select, as long as you solve for a single variable. So I can take the first equation or the second equation to work with. I'm going to take the first equation. I have the 9x minus 74 equals 7y. Now there's a few different approaches I can take here. I can solve for the y by dividing the 7 out through everything. Divide the 7y by 7, the negative 74 by 7, and the 9x by 7. I could also solve for the x by moving everything away from it and then dividing by the 9. I'm going to solve for the x. It's a little bit longer, but it gives us a little bit more to work with as an example. So I have the 9x minus 74 equals 7y. The first thing I want to do to solve for x is to move that 74 away. So it's a negative 74, so I sum the 74 to both sides. This takes it down to 0 on the left, and it adds a 74 to the end on the right. Now I have that 9 to move. I'm going to get rid of that 9 by dividing it out. A 9 divided by a 9 takes it down to a 1x. Then I have the 7 divided by a 9, y, plus the 74 divided by a 9. So I've solved for x. What I'm going to do with this is now take this equation and plug it into the second equation where I see the x value. So here I have the negative 3x, so I plug in my x value, a 79y plus 74, 9. And then I continue to carry on by just copying down the rest of the equation, which was a plus 4y equals a negative 23. So plus 4y equals a negative 23. Now I need to simplify. I first clear the parentheses to simplify. I distribute that negative 3 through the parentheses. I end up with a negative 7 over 3y plus a negative 74 over 3 plus my 4y, which I've put over a 1 just to keep it in fraction form with everything else below, so that when I get to the point where I want to combine like terms, I can just immediately rewrite it into its equivalent fraction. I see that I have a 3, and a 1, so the lowest common denominator here is a 3. So the first two will remain the same. The 4 over 1, however, needs to be rewritten to its equivalent fraction using a 3 in the denominator's position. So 1 times 3 is a 3. Whatever I do to the bottom, I do to the top, so 4 times 3 makes 12. Now I'm ready to combine my y's. A negative 7 and a positive 12 make a positive 5 over 3y. Plus a negative 74 over 3 equals negative 23. Next, I want that y by itself, so I'll subtract that negative 74 3 to the other side, which results in a summing. So I'm going to sum 74 over 3 to both sides, taking the left to a 0, and I'll just tack it onto the end on the other one, so that I can write out the equivalent fractions so I can sum them properly. So I have a negative 23 over 1 plus a 74 over 3. So now, writing the equivalent fractions, I would use a 3 in the denominator's place. So 1 times a 3 is a 3. Whatever I do to the bottom, I do to the top. So a negative 23 times a 3 makes a negative 69. Now I can sum those. A negative 69 and a positive 74 leaves me with a positive 5 over 3. Lastly, take the reciprocal and multiply it to both sides to clear the fraction away from the y. So that takes that down to a 1. I end up with a 3 over 5 multiplying to the 5 over 3. Those cancel down so that I'm left with y equals 1. So I now know the y value. Next, I need to find the x value. So I'll take one of the two equations from above and plug the 1 into it. I'm taking the second equation here. You could also run the first equation as well as a check to see if you come out with the same answer for x. So I plug a 1 in where I see the y value, so I have a negative 3x plus 4 times 1 equals negative 23. So I end up with a negative 3x plus 4 equals negative 23. Subtract the 4 off both sides. I'm left with a negative 3x equals a negative 27. Then divide out that negative 3. Negative 3 into negative 27 leaves you with an x equals 9. So my ordered pair is 9, 1. Question number 8 reads, the perimeter of a rectangle is going to be 70 meters. If the widths were doubled and the lengths were increased by 23, the perimeter would be 136 meters. What are the length and width of the rectangle? Well, let's start by finding the first equation. Let's first assign width and length each a variable. If we let x equal width and let y equal length, we can now move on to our formulas. We know that perimeter is P equals 2w plus 2l, or 2 width plus 2 length, or P equals 2 times the width plus the length. Let's plug in what we know. We know that the perimeter is equal to 70, so we plug a 70 in here. We also decided that our w would be an x, so we'll plug an x where the w is, and that our length, L, would be a y, so I plug in 2y. Now, I can show here both of them, right? The 70 equals 2x plus 2y, or the 70 equals 2 times the binomial x plus y. This gives me my first formula, but I need to come up with a second one, and then I can use one to solve the other. So, with the other information that read out of the sentence, I was told that if I were to change the perimeters, okay, to 136, let's come back up to the question. If I changed the perimeter and it was 136, I know that this situation will occur if the widths were doubled, or 2 times the width, and the lengths were increased by 23 meters. That means I'm adding 23 to the lengths. So let's come back down here and do that. So I have a perimeter of 136 equals, I'm going to use this second equation where we had 2 times the width plus the length. I'm going to plug these in. So on the other side, using that formula, I have the 2, and then in parentheses, I know that I'm going to double the width. So I called the x the width, so I'm going to take 2 times x plus, and it says in the formula, if I added 23 to the length, so y plus 23. Now let's simplify it. We'll distribute the 2 through the parentheses. So I end up with 136 equals a 4x plus a 2y plus 46. I'm going to continue to simplify this thing. I'm going to subtract the 46 off both sides so that I find 90 equals 4x plus 2y. So now I have a second formula. And if you look at the two formulas I have, the 70 equals 2x plus 2y, and the 90 equals 4x plus 2y, I also have them in the same form with one another. So I can write these and use elimination method to solve for the problem. So I'll take my second equation, my 90 equals a 4x plus 2y, and subtract from that my 70 equals a 2x plus 2y. This results in a 20 equals 2x. My two y's cancel. A 2y minus a 2y equals 0. Now I can divide the 2 out because I'm just left with an x, and that leaves me with x equals 10. We know that the x, when we look back at our problem, was our width. So we know the width to be 10. Now we're going to substitute the value from above, equation 1, so we solve for y. So we're going to take the 70 equals a 2x plus a 2y, and we're going to substitute that 10 in there. So I end up with a 2 times the 10 to make a 20 plus 2y. Now I'm going to subtract the 20 off both sides, so I get 50 equals 2y. Lastly, divide the 2 out, and I get a 25 equals a y. So my width was 10 meters. When I look back, I saw my units were meters. The meters do need to be there in the final answer, and that my length is 25 meters. Moving on to question number 9. This one says to solve the system of equations using the elimination method. So I'm going to come down here, and I'm going to set up my equations. I'm going to use the elimination method. That means that one of my terms from each equation have to match one another so that I can sum these together and eliminate. Well, what I see is that I have that negative 4x plus 8y equals negative 12 in the top one. If I had a positive 4x in the bottom, then I would be able to eliminate this when I sum the two equations together. So to get this 2x to a 4, I need to multiply it by a 2. But whatever I do to one term, I need to do the other terms in the equation. So I'm going to multiply or distribute a 2 through to every term. So I'm going to take a 2 times the 2x to make a 4x, a 2 times the negative 5 to make a negative 10y, and then a 2 times the 6 to make a 12. Now I can plug that equation back in with the first equation and sum them together. So I have a negative 4x plus 8y equals a negative 12, with a 4x minus 10y equals 12. When I sum them together, the x's cancel, and I'm left with a negative 2y equals 0. So when I divide out a negative 2, I end up finding that y is equal to 0. Now I can take that value for y and plug it back into one of my equations above to solve for x. So I'll take the first equation, the negative 4x plus 8y equals negative 12, and plug that 0 in on the y position. So that I'm left with a negative 4x equals a negative 12. Divide out the negative 4 both sides, and it leaves me with x is equal to 3. So my ordered pair here is going to be a 3, 0. Now this is an ordered pair, so don't forget to put it inside its parentheses or it's not completely correct.